Hi, I'm Larissa and today I'm in Enschede to have a look at QuiX Quantum. They are developing the most powerful processors in the world. That sounds interesting. Let's have a look. I think I have to be in here. Yes, hey Marcella.
Hi Larissa, welcome at QuiX Quantum. Come on in and they are going to show you the Quantum Lab.
So before we go to the lab, maybe you can tell me something more about the company.
So QuiX Quantum is a small 3-year-old startup. We've got 13 employees. And we design and characterize and sell these photonic quantum processors that are shown in this picture behind us. There's 400 little heaters, which are behind these gold leads, on top of optical waveguides that, where the light comes in and goes out. We can do fundamental science, or we can solve problems for real companies.
So what happens before the quantum experiment?
Michiel down in the characterization lab will tell you all about it.
Okay, let's go. Hi!
Hello.
What are you doing?
So over here we are characterizing our 20-mode photonic processor. So right now I'm measuring its reconfigurability. That means I want to study how well I can implement the settings for the transformation of the light that I want to implement.
Okay, and what is the difference between this lab, what you're doing, and the other lab?
So in this lab we do a classical characterization, which means that we just characterize what's happening on the photonic processor. And then in the other lab we use the photonic processor for performing quantum experiments using quantum light.
What's over here? Can I have a look?
Yeah, have a look at it, please.
I see red lights. What is it?
So over here we perform our visual inspection of our devices. So we inject red light on a chip and then we can see if there's defects on the waveguides or if there's errors or mistakes in the design. And then if everything looks good and the light goes nicely through the chip, we can select it and we can assemble it into a photonic processor. And then afterwards it goes to the other lab for the quantum experiments.
Okay. Well, so if it's perfect, it will go that way.
If it's perfect, it goes to the other lab.
Okay. And what are those boxes?
These are our devices that we measure and that we then ship to customers.
This is our second lab where we do quantum mechanical experiments. Come in. This is where we actually do quantum science. And so we wanted to show you a little bit about how our whole system goes together, not just with our devices, but as a whole ecosystem. So in this little black device here is where our quantum dot light source is. This is where we generate individual photons to go into the chips that Michiel showed you. Because without quantum light, we're not doing quantum science.
It's not that light, right?
So this emits only a single particle of light every time we ask it to.
And what is the sound I'm hearing?
So the sound you're hearing is our refrigerator, and it's not just a normal refrigerator like everything else around here, it's the fancy version. So this fridge goes down to minus 272 degrees to keep our detectors cold. Detecting those individual particles of light is very difficult, and so we use superconducting detectors, each of which can detect a single photon with 80% probability.
So what's the point?
So if we take our quantum light source and we connect it to our quantum processor and then to our detectors, we get a quantum computer. And with that quantum processor, we can do fundamental science, or we can solve problems for real companies.
Okay, well, thank you, Devin, for the tour.